Okay, so video number 3 of our AI series here, and just FYI, I'm going to do one more once we're done with this, and it will cover some more advanced topics and essentially a different way of doing everything we've done to date. And not necessarily a better way, but definitely a better way if you want some more advanced type of AI behavior. But just as an aside, all this should be informed by your playtesting and what you really are looking to do from a design standpoint. So don't over engineer things. So if you watch the last video, not the prior one, but the last one in this series, which will come after this, and it's on AI and behavior trees, don't feel like you need to, that you're less of a designer or a programmer if you implement what we've done to date. As long as it works, then it's totally fine. Okay, so what I think I want to do now is right now we have this AI chase controller. Let's just remind ourselves where we're at. I think I ended by doing a little play test myself here and grab some of these, and I'm slowing down and he sees me and try to get away, and it appears that I'm in big trouble unless somehow I can get away from him. Okay, perfect. And then maybe grab that one. That wasn't smart. Yeah, and he sees me. Now I'm dead. Okay. Anyway, so we did some of this, and already it's enough for you to go out and maybe do a little bit of more white boxing. If you go all the way back to the first video, and a little more level design, and play some of these and see if that's something that works for you. But I also want to make another type of AI, and I want to also use this chance to introduce something called inheritance. What this is actually pretty cool. So let's say we have this chase controller, and just remind you what it does. Is in the last video, we went ahead and added some logic to tell us if the perception component was being updated, and if it was being updated, we were just switching between, if I successfully sense something, which is I successfully see every time the perception component is being updated, then I'm going to say move to the actor, and if not, I'm going to stop movement of the AI controller, and by default the pawn that it's controlling, and that's where we got. And all this is done here in our onPerception updated event. So let's dock this here. So let's say we like that behavior. We feel like we've got this behavior where you get in within range of a perception component, and then it's going to chase you. And then when you get out of range, it's going to stop all of a sudden. And maybe it's not totally natural though, but we like that idea of being able to keep all that work that we did. But we want to create a new type of AI. And so in this video, we're going to create an AI that path finds. And that AI is pretty much going to be able to go between one or more, well, obviously more paths. So think of it like a guard AI. And if I can transition over here to my tablet, I'll try to draw at least what I'm expecting us to be able to do here. So again, if we have our play space, let's put it here, and then we've got our enemy here, and we've got our player here. So what I want us to be able to do is I want us to have our enemy kind of path between two spots, these two spots here, maybe spot 1 and spot 2. But I also want the option for us to then add a third point, maybe here, and so he may go to wherever you drop him. He'll go to point 1 here. We can specify and have like a visual marker. So as we're doing some level design, we can easily move that around. And then he'll go to point 2, and then he'll go to point 3. And why don't we just make point 4, and then back to point 1? So essentially do a path, right? And this path is one that we can specify ourselves and move things around. So very simple guard AI, but if the player gets within range within the sight radius and the field of view, we want the enemy to immediately, execute this other AI function that we've developed here and go chase the player, right? So that's what we're going to do in this video. So let's transition back here and see how we might do this. So the first thing I'm going to do is right-click on my BP AI Chase controller and choose Create Child Blueprint Class. And what that will do is it will create a child of the AI Chase controller, meaning it's going to have all of the things that we already did, all of the functionality, I should say, and the components that we already have within that controller. It's going to give us a new one, kind of not a blank slate, but one that we can work with that has additional functionality that's contained within it. So we don't need to duplicate any of the work that we did in the AI Chase controller, which is pretty cool. So I'm going to name this AI BP underscore patrol controller. Okay. And I think what we can do is, let's make a new, do I feel like making a new pawn for this? I do. So right click on this here, and instead of going create child blueprint class, we could do that. I just want to choose duplicate, and that'll duplicate it. BP underscore patrol dude. Let's keep it like that. Okay. So they kind of look, well, they're exactly the same. So I'm going to double click on this, and the one thing I'm going to change is the AI controller class, and I'm going to change it from chase controller to patrol controller, and then just done. So I'll close this out, and I'll close out the chase controller as well. Okay. And the last thing I'm going to do just to set us up is I'm going to take this baddest dude that we have that just chases us, delete him, and place the new one, the patrol one, in here. And so just to prove to you that our activity of making that blueprint, that child blueprint here is working, if I play this, it should chase us. Yeah, perfect, right? So it does all the things that we expect it to do. And if I open it up and go to the event graph, there's nothing here. In fact, it shows that we're inheriting all of these other components that we had, including the AI perception component that we added, and it has this site radius and lose site radius. And so, for example, if we go to our AI chase controller, we just select our AI perception component, and we change this site radius to whatever, 801, and we go back to our patrol controller, it's also 801. But if we change the patrol controller to 800 and we go to our chase controller, it's still 801, right? So the child inherits from the parent does not inherit from the child. So this gives us another layer of control, specifically for this AI controller, and then by default, the new pawn that the one that we duplicated. So this is kind of already, I think you're seeing like, oh wow, I can quickly make different variations of something if I want to put my main kind of AI logic for a type of enemy at a top level, then I can make many different ones quite easily that flow down from that. Autosave, sure, save now. Okay, so now that I've proven to you that that is true, let's go ahead and think about what we want to do here. Yeah, so what I want is, I kind of essentially want to be able to have a function where I can, have the AI move to this point, and then it turns around, and then it moves to another point there, and does the same kind of thing, just moving along a series of points that I place in the world. So that is what we want to do. There's many ways we can do this. The way that I think is going to make the most sense, or give us the most flexibility, again, because that's kind of one of the big rules, is I want us to continue to maintain our flexibility and not commit immediately to one particular mechanic. I want to create a new actor. So I'm going to right click here. We can do this in our NPCs folder. Right click, go to blueprint class, new actor, kind of base class. BP underscore path node is what we're going to call this. And what this actor is going to be is, we're not even going to we'll render it in the world for now so we have something to look at, but this is going to be the path node, and we can add multiple of these, and we're going to cycle through them and well, we'll have the AI cycle through them and use those as new positions to move to. So opening this up, I need something kind of that I can see. So I'm going to choose a component of type billboard. It's a 2D texture that will be rendered always facing the camera, like a billboard. I guess that's what it's called. It's some 2D texture. I guess it comes with a little raptor there. Okay, great. And what I want to have in this actor, let's see here. I think what I want is I want these actors to hold within them a variable that's exposed to the level designer, in this case us, that says next node. So this would be the next node for the next node variable, and it's going to point to this same type of actor as we place them around that we're able to select. So it makes it, we'll see in a second, but we'll be able to add many of these in the level. So the variable type should not be Boolean. The variable type is actually going to be BP underscore path node. And so this might be the first time that you've seen this before, but we can not only have like these primitive variable types, you can also have variable types that are actors that you've created. And if I do BP underscore, you're going to see some of the actor types that we've made already. And so in this case, we made an actor type called path node, and we want to get a reference to that. So we're going to be able to put other path nodes that are around our level and select those as our next node. So then the last thing we want to do is variable is public. So we want to set this to be a public variable, compile that, and close it. And so now, if you take this path node, drag it off into the world, I'm going to press P as well to remove my nav mesh and zoom in. Here's our little raptor. I guess we don't even really need that. We can remove it later. But anyway, dropping that into the world, you see this thing says next node, and it's none. So let's drag another one in here and put it over on this side. And then under next node, what I want to do here, well, I'll select the first one that I added. You can use this eyedropper here, or you can use the drop down, but it's actually probably more useful in our case to use the eyedropper. Click that, and then you can select a compatible node. So you notice I try to mouse over this or this, it's saying no, it's not compatible with that variable type, but this one is. So I can choose that, and then it will just choose that as the next node. And then I want to select this one, eyedrop, and I'll choose this one. So they're pointing to each other. So the next nodes are now, so let's say our character will move here, and he'll turn around, and he'll move here, and then yada yada. So that'll be in perpetuity. So where do we put this logic to do that? Makes a lot of sense to put it inside our patrol controller. Right. So what we want to do in the patrol controller first is when we begin play, actually want to get all actors of class. We've used this before. And this will get all the actors that are in a particular class, and the class is the one that we made, which is path node, bb underscore path node. So we'll get all of those. And then what I want to do, okay, so I've got all of those things. So I'll get a whole branch of them. And just so you know, my thought process right now is I want, no matter where we drop one of these patrol enemies, I want them to first go to an active path node, or a path node that maybe we say is an active starting path node. Okay, so I'm already making sense to myself. Probably not to you, but it'll make sense in a second. So we actually are not done with our path node actor. So open this one more time, the path node. So right now I said, well, we have this one variable, it's next node. We need another variable that's a Boolean, and I'm going to call it is start. And I'll make this public too. And so if this is selected as true, then we want to make that one an eligible node for the AI to move to. So now back in the AI path controller, so I'm going to close out path node for real now. Back to the AI path controller. I want to branch here. Do I want to branch? No, not yet, but I'm going to want to branch. So first I'm going to get all of those nodes. That will return an array. And then we'll do for each loop. So for all of the path nodes that are in the level, I want to check is start. So I'm checking is start. So if you notice what I did here, each of those will have that variable associated with it because it's reading that from path node. And in path node we added this new boolean called is start. So it's going to check is start, and that's the condition that we want. And if it is start, then we know we can at least start, right? That because this is begin play. This is going to happen one time when we press play. We want to move to location. Yes, I think we could choose move to actor. Let's see. Yeah, and then that's fine. Okay, that'll work. I want to make the lines a little prettier. But let's just, before we waste time on that, let's make sure this will work. Okay, so let's comment this. Something I'm promising to do more in these videos is, okay, when we begin, get all of our path nodes, check to see if is start is true, and move to the first one that satisfies that condition. Okay, so that's what we're going to do. And because we already have our AI perception and all this other stuff, this should work. So the last thing we need to do is set one of our nodes here, since we expose this as a public variable, is start to true. So once we do that, and let me go ahead and I'm going to see if simulate will work, and it did, right? So you can see it'll move here and it'll stop. And no matter where we put it in our nav mesh, it's going to go ahead and figure out the fastest way for it to be there. Actually, what are you doing? Why did you stop there? Let's try to figure out why it's stopping. Let's see. Tasks, AI, perception. That's very strange. It might have something to do with the player starter getting stuck in there or something. So, okay. Let's try it. It should stop there. Okay, right. So we know that's working. So on begin play, but that's not what we want. What we really want is we want it to go there and then to start patrolling back and forth. And so the place that we want to put that logic is going to be in our tick function here, because that's going to continue to generate or to continue to fire every single frame. Right, so let's start building that out. Definitely one thing I don't want to happen already is, like, if we're firing the tick function as it's moving to that to its destination, if we keep telling it to go to the next destination, it's gonna freak out and never make it to either one of them, because it's gonna fire many times. So I need a way to say, if you're not moving, if it's not moving, it meaning the AI or the pawn, then go to your next spot, right? But if you are moving, block it, block any movement. And so what we can do from that one is, I think we want to there's something called an enum, which is another type of variable. And an enum, think of it like it stands for enumerator, but imagine these as just defined lists that you can choose from, and it'll literally look like a drop down once you do this. And I think it's called, so it's on a navigation mesh, has a navigation, so I think it's called get nav state, get move status. Okay. Wow, I even type nav and it has that. That's very cool. Okay. Yeah, this is it. And I can tell because I know these colors well. So this dark green is an enumerator value, and the value is specifically ePath following status enum, right? So this will tell us if it's following a path or not. And I'm going to drag off and do an exclamation mark, which says not equal. You could do equal, but I think we want to look at the, we're going to make a branch, and I definitely want the branch to say the positive condition rather than the negative one. And so, you know, when I was preparing this video, I didn't really know exactly how to do this, and then figured out, well, this is cool. There's an enumerator that exists that will tell us the different states of our AI, and it's idle, waiting, paused, and moving. And these are states as it's, you know, following along a path. So we want is not moving. So if it's not moving, then this will return true. And now we can add our branch off of our tick function here. Perfect. So what this will do is, as tick is happening, this will block anything if the pawn is moving. And if it isn't moving, that's where we can do something else, which is another move to actor. So then we want to move to the next node in our but that next node here is the next node is dependent upon the current node that it's moving to, and we're storing that next node value. If you recall, we're storing that in the path node. Next node is here. And so as we place those around the world, you know, we place a path node, we placed one here, and we placed one here, we then said what the next node was going to be. And so this was, again, to give us that flexibility that if we wanted to add, you know, we want to add one here, but then we don't necessarily want it to go around in a circle. We may want to make some very complicated types of paths that the AI follows, and have all of that flexibility there. Then we have it because we can select what the next node is going to be. So we've done that for these two, and we've created a kind of an endless loop of back and forth. So that's great, but we need a way to get that. And so where's the best place to store it? Well, what we're not doing here, which I think we want to do, is we need to do this up here. Okay, so we also need a variable in our path controller here to store the next node that it's going to go to. I think that's the easiest thing to do. So create a new variable. Let's call it next node, and then it's going to be of type, you guessed it, BP underscore path node. Okay, and it's a reference to that. We don't need to make it public because we're going to set it. And so how are we going to set it, and where are we going to set it? So we want to set the first one up here when we do our begin play. So this way, when we tick and we can call that, and then we can continue to set it again. So as I'm talking, I'm making up my mind. Like, so generally when you know how this stuff, when you know how to think logically within the frameworks here, you end up kind of doing half the work for you. So I know on tick, after I've told my AI to move to the next location, I need to then set the next node, and the next node will be a function of whatever I'm going to set up here. So let's disconnect this. Should I disconnect my goal too? I will, just to make some room for nice blueprinting. Right. So, so we have something is true. Okay, and then I think what I want to do is from this actor here, I already know it's a path node, so I want to get next, get node, let me see what I called it. I called it next node, so get next node. Okay. Get next node. We should be able to get that directly. Let's try this. Get next node, take off context. Okay. Let's just make sure this works, and then that's very strange. Okay, so just to tell you what I did, I knew that I was going to get back, I'm getting back an array of path nodes here. And, you know, so from that, I know that there's this variable sitting on them, and I wanted to just get it. And I'm typing, oh, okay. I'm typing, oh, because context sensitive is off. So sometimes it's not digging down enough. So if you know that you're doing something correctly, if you uncheck context sensitive, you can grab that. It should be get next node. Get next node under the path node, right? Not under ourselves. We named it the same thing. Not always a good practice. And then plug this in, and then we then want to set here. So, okay, perfect. Okay, so what this is going to do is going to take the next node that we specify that's sitting on that actor blueprint, the path node blueprint that's here, whatever we've set for that, and it's going to set it as our local variable in our controller so that we have a reference to it. And that's really kind of all we need to do there. And I guess we can do one more of these as the goal. And then, gross. I'm going to just add another reroute node. Okay. Not bad. Okay. That's fine. All right. So now that we have next node and we're storing that next node, it's an actor reference, right? So we can grab this out, we can get that, and it becomes our next goal, right? Almost done, right? So like we should stop here and play and just make sure then what we're expecting to happen is the one that's marked is start here. Okay, this guy should move here, and then he should move here, and we don't know what's going to happen. Let's play. Looks good. Moves there, and then moves there. So cool. Okay. And then it stops. All right. And why does it stop? You probably noticed we're not setting this value. So that's the last thing we need to do. And if we drag this in here, no, that's not how it's going to work. Because that will just set it'll just set itself to the same thing it was at. So what we need to do next node is we need to get the variable of that next node. So really now I'm realizing I should have named these two variables something else so they made more sense, like local next node and path nodes next node or something. So if I can go ahead and do, you know what, I'm going to take it from up here. So I'm going to copy and paste rather than use the right click. And then this will pass me, yes, perfect. So this will look at you, this will basically use the target will be this actor here, and then within that actor we have the next node variable, and that will set next node. And then provided that we are not moving, then the next time tick functions, goal is going to get updated because we've already set it, right? So we set next node here to the next node that was within the node that it had moved to. Okay. Confused? Hopefully not. If you are, just post in the Slack channel because this confused me the first time too. So if I play it, awesome, it should go back. And it does. Okay, very cool. And forever, we are forever in this loop of patrolling. Okay, so before we do the last thing, which is more like kind of cosmetic or just to prove to you that this is a extensible gameplay system here, is if we play, we see that he's going to path. So what do you think is going to happen if I get within the site radius or field of view? Well, you probably guessed it, right? It should chase me, and then it's chasing me, right? It's still chasing me. Okay, it lost me. And here it goes back to pathing. I'm gonna get, yeah, perfect. Neat, right? So one of the things that like we've done, and we'll cover this in the next video in a lot more detail, is we've created a pretty simple AI, and we have kind of two things that we did. One, we just did this chasing one, and then the second thing we did was we extended that blueprint class to a child, and we added a little bit more flair to it. Really, we gave it the ability to patrol between 2 or more points. And so let's say we want to take path node 2, and maybe this is the path. So let's go top-down view. You know what I'm gonna do? Let's remove all of these, and let's keep him as a kind of the guardian of this one here for now, just so we can keep it clean. So we've got our first path node, and that's marked as is start, and we've got a second. I'm gonna just hold Alt and drag out to create a few more. And now instead of having next node be path node, I'm gonna again use my eyedropper here and make this the next one. Select this one, eyedropper, this one, select the third one here, eyedropper, this one. Okay, so now we have kind of a full circle here. It's gonna, I think I can draw a line yet. So he'll go here, then he'll go here, he will go here, and then he will go back to the start and ad infinitum, right? So let's go ahead and go to perspective and play. And so I kind of already know. So he went to the first point, second point, third point, fourth point. Yeah, neat. So here we are, very simple path find with an addition of a kind of a see and chase, and then you get out of the vision. It will go back to pathfinding. It's going to go back to its start, right? So there's more work to be done. And just as a precursor to the next kind of optional video is just what happens is these blueprints can get quite complex, especially as you start to say, well, in this particular situation, we don't want this to happen, or maybe the order of operations is totally wrong. And so in the next video, we're going to cover behavior trees, introduce what those are, how they're used within the Unreal Engine for specifically around AI, and how they can be extended to create some pretty advanced behaviors. But again, if you don't need them, and this is good enough, and I think it is for certain cases, then go off and start doing more level design and more playtesting. And then once you do hit a problem where you're like, this is too complicated, at least you'll know, if you choose to watch the next video, you'll know that there's this other option to explore to kind of make things easier on you as things get more complex. Okay, thank you.